Okay, so in the last video, we talked just a little bit about orbital diagrams and how we might write them, but we also have other ways to denote that same information, and one of the ways we're going to talk about is called an electron configuration, okay? So an electron configuration. So electron configurations are compact ways to denote the location of the electrons in the orbitals. So on the right-hand side of your screen here, you can see all those orbital diagrams that we looked at before. However, you can see the electron configuration for that same element in the center here. So this is the orbital diagram for boron, and this is that same information in that orbital diagram written out in a much smaller way. So they make it so much easier to see what's happening without having to take up so much paper, so much space, drawing out all those boxes, putting all the electrons in, so on and so forth. So it can be harder to see and figure out how many electrons there are right away in each orbital when we're looking at orbital diagrams, but it's much easier to see those things with an electron configuration. And the kind of downside, though, to an electron configuration is it's a bit harder to see if you have unpaired electrons. And those have a little bit to do with maybe magnetism or some of the chemistry they can be involved in with as well. Sometimes it can be useful to know those unpaired electrons, which is why an orbital diagram is great. But sometimes it's better just to know how many electrons are in an orbital. So an electron configuration can serve the purpose just as easy. So electron configurations use letters and numbers to note the same information as the orbital diagram. So here, what this is telling us is that we have the 1s orbital, and that exponent piece is the number of electrons in that orbital. So this is 1s with 2 electrons in it, 2s with 2 electrons in it, and 2p with 3 electrons in it. So that correlates right here. 1s with 2 electrons in it, 2s with 2 electrons in it, 2p with those 3 electrons. Okay, so 1s2, 2s2, 2p3. Okay, so that's kind of what an electron configuration looks like. Not that there isn't much else to say about them, because again, they contain all of that information, everything we talked about with the orbital diagrams. So I'm not going to rehash that for you. Again, it can be a bit harder to see how many electrons there are right away in an orbital diagram, but it's much easier to see how many electrons you have in the electron configuration. So how do we go ahead and write these electron configurations? I'll show you kind of 2 different ways here first. The first way starts with just draw your dang orbital diagram. So follow all the steps and triple check you followed the rules properly. Then you just can write down your orbitals. So you would always go from lowest energy on the far left of an electron configuration, highest energy on the far right, and then you use a superscript or an exponent to write the number of electrons in the orbital for each. So, for example, that was that 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6. So it fits into this little rhythm. You'll hear me say that all the time too. I'll be like 1s2, 2s2, 2p6, and I'm like tracing it on the periodic table trying to figure it out. So one thing I really want to point out here is that it's really, 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 really important that you make sure you're using superscripts or exponents, because if you don't do that, I can't read like what's on the screen here. I cannot read that 1s22, s22, p6. I don't know what that means. So it's important that you make sure that you have that information written out properly. So let's go ahead and do 2 examples where we use the orbital diagram to write the electron configuration. It always takes me a minute because I have to remember which one I'm talking about. So let's do the orbital using the orbital diagram, let's write the electron configuration for beryllium. So we already did the orbital diagram for beryllium in the last set of slides. So You can go back and see how to write that orbital diagram for beryllium, but let's do it, or use that orbital diagram that we previously wrote to figure out the electron configuration. So this is the electron configuration for beryllium. So if I'm using that orbital diagram I see on the screen, I can see that this is the 1s orbital and the 2s orbital. So that 1s orbital has 2 electrons in it, and that 2s orbital has 2 electrons in it. That's kind of pretty straightforward. So it's 1s2, 2s2. 1s2, 2s2. We also have the orbital diagram up there on the screen for bromine. We did that in the last video as well, so go check it out. But let's do the electron configuration for bromine. So that would be, again, you're going to write what you see in your orbital diagram. So I would say that's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, I'm running out of space here, 4p5. So the electron configuration for bromine looks like 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. I kind of like I'm cheating here. 4p5. Okay. So you can see it. Oops. Oh, you can see that electron configuration written out here in one straight line on your screen. So go ahead and check that out. And then we're actually going to do the same example for chlorine as well, but I'm going to show you just a little bit different of a way to do that orbital diagram for chlorine. Okay? So we also could just use the periodic table to do this. I highly recommend you draw the orbital diagram, but that's just me. If you want to do it using the periodic table, this is how you'll figure it out. So we're going to do that orbital diagram for chlorine. So chlorine's over here. It's number 17 marked with the red dot on your screen. So we could do it using the periodic table. How do we do that? Well, what you do is you determine where the element lies on the periodic table, which block it's in. So all of those orbitals below that last highest energy orbital are going to be full. So I can already know that that chlorine is in the P block and it's in row 3. So that highest energy orbital is going to be 3p. So I know the 1s2 is full, the 2s2 is full, the 2p6 is full, the 3s2 is full. Done. And then from there, I can count the number of electrons in the outermost shell. So it's kind of like when we were like going from the orbital diagram and looking back to figure out what element we had, we can kind of do that same counting. So this p orbital, if this is chlorine, would have 1, 2, 3, 4, 5 electrons in it. So that tells me chlorine is 3p5. So we could do it that way as well. So that's the orbital diagram there for chlorine. And I showed you 2 different ways there that you can figure out the orbital diagram. So that being said, I've given you some practice as well. You can determine which way you want to do this, which kind of pattern you want to follow to write out those electron configurations. But just like we did with the orbital diagrams, you should also be able to look at an electron configuration and figure out which element you have. If we want to do the first example that I have written here, and I have something that is 2p4, or it's 1s2, 2s2, 2p4, that information I zone in on is 2p4. That highest orbital is going to tell me the information about where this is located on the periodic table. So I'm looking for 2p4. So let's go back to that periodic table. This would be 1s2, 2s2, and I want 2p. So this is 2p, and I want number 4. 1, 2, 3, 4. So that's oxygen. So let's go ahead and do the next one. The next one says 1s2, 2s2, 2p6, 3s2, 3p6. So let's go figure out who this is. So I'm going to zone in on that highest energy orbital, 3p, and it has 6 electrons in it. Let's hit the periodic table. So I have 1s2, 2s2, 2p6, 3s2, 3p1, 2, 3, 4, 5, 6. 3p6, that is argon over here. 3p6 is argon. So that guy there is argon. Okay, let's do another one. We have 4s2, or sorry, the whole electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6. And 4s2 is the information we actually care about. So let's go figure out who 4s2 is. Periodic table. Should have put one on every one of those slides. I don't know why I didn't. Sorry. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. 1, 2. 4s2 is calcium. 4s2 is calcium. Calcium. All right. Let's go ahead and do that last one. That says 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p2. So we're going to go look for whoever is 5p2. Okay, you ready? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, remember the D's start with 3, so 4s2, 3d10, 4p6, 5s2, 4d10, and then I want to know 5p2, well 5p2, 1, 2, that is going to be 10, so that Sn, that's 10, we have 10 there in our electron